Hello and welcome to the first ever digital Docker London. This is all going to be very unusual for me. Let me just put my presentation on the screen. Look at that. This is it. Isn't this fun? All right, so welcome again to Digital Docker London. I am coming at you from my living room, as many of us will. This is my house. So, who am I? For those of you who have not had the pleasure of meeting me in person yet, my name is Dominique Top, and I am also known as Electronique or DevOps Dom or DevOps Dommy. I am currently a solutions engineer at HashiCorp. Got a new job, guys. Got a new job, girls. Okay. Anyway, I've been community leader for Docker London since 2.5 years. I also co-organize Cloud Native London. I'm on the organizing committee for DevOps Days London, which is, also affected by current situation. And for those of you who may have met me in person, I'm also a karaoke aficionado. You can follow me on Twitter on DevOpsDom. Everything will be recorded tonight, so don't you worry. Everything will be visible afterwards. In case you haven't noticed, if you're watching via YouTube, which I think you are, I don't think the chat's been switched on, but I would like you to head over to the Discord server that we've made specifically for our digital meetups. If you type in docker.london/discord on your browser, it will lead you to our Discord server. Please read the community covenant, which pretty much is our code of conduct. And if you hit the like button in the bottom of the welcome channel, you'll be given all the other opportunities in all the other channels. So afterwards, obviously, you can get the YouTube videos via here. If you want to get involved for the next time, please head over to docker.london/get involved. And you can find us on Twitter at Docker London and hashtag Docker London. There we go. Yeah, so I just wanted to do a little shout out for our sponsors because even though it's a very challenging time for everybody, I felt like we should probably just note it. Obviously, JetBrains and O'Reilly, but also Technovo is a digital transformation consultancy providing expert partnerships and growth without creating dependencies or disrupting culture, which is why they're proud to sponsor Docker London. Community is truly at the heart of everything they do. There are two ways you can find out more about Technovo. You can chat with Megan, their community advocate who's in the Docker London Discord channel. Her handle is her name. You can also follow Technovo's LinkedIn page where they post the latest updates and blog posts. Docker London is also officially partnered with Meetup Mates, as you may know, one of Technovo's community initiatives. The idea behind the initiative is simple. No one should feel like they can't attend events that they're interested in simply because they have no one to go with. Given we're in strange times, community is now more important than ever. Meetup Mate Slack channel is where everybody is, so there's still like a social gathering happening. There's some virtual events happening, and you can pretty much discuss what you learn over there. You can head over to meetupmates.com, where you can also sign up. And remember, meetups are better with mates. So, just to talk a bit about the things that we've missed. Like, I don't want to talk about it too much, but this is just a small, overview of the things that I've personally missed. To start with was the Docker birthday, which was supposed to happen in March, which was a bit of a shame because I've now have like 200 t-shirts and a bunch of books in my house just like waiting to be handed out to you all. But not going to the pub, not meeting your family, not meeting your friends, and going on holiday. It's literally everything's been cancelled. But the things that we have gotten in return is stuff like this, like being able to, connect with each other on video conferencing or virtual meetups or virtual events like this. Like I had my birthday in lockdown, and for those of you who've known me for a bit longer, I tend to celebrate my birthday for at least a week, and I've done that since I was 18. That's 14 years for those who've been counting. And I was, yeah, kind of sad about, not being able to celebrate my birthday with my friends and like not going out and like do stuff because I like doing stuff. I'm an extrovert. I like, being out and about with people. So, yeah, that could be quite sad, but like in return, I got like one of my best friends organized a Zoom quiz. She literally like put so much time and effort into creating a full-fledged 4-hour quiz, and then afterwards I had another Zoom session with a bunch of friends. Like we played Cards Against Humanity at like 2 a.m. and that was great. Like that was the first time where I was like, you know what, like this is actually not bad. Like I feel very privileged to be able to work from home and uh, stay connected with the people I know, and I know that there's lots of people that don't have this as much as we do. So I just like want to check my privilege a little bit, I guess. Anyway, moving on, because this is a happy time. Because I said earlier, JetBrains is one of our sponsors, and they have kindly provided us with 3 1-year free JetBrains licenses. They've been a great support for us as well. So what I would like to do for today is the 2 best Q&A questions will get a free JetBrains license. So that will be picked by our speakers, and one of the tweets that will go out today. So get tagging. I mean, we can still take pictures of your screens. Hashtag Docker London, and the winners will be announced after the event. Some other community updates. We've got Cloud Native London, which is they've been pretty much like on it every month. Cheryl is great with stuff like this. She's been remote for years, so she's doing a great job with that. So June 3rd is the next one. I've been told by my friends over at London DevOps that their next edition is going to be on June 11th. But watch that space on meetup.com. And then, because I now work at HashiCorp, HashiConf Digital is coming at you as well, and that's going to be on June the 22nd to the 24th, which I'll also be emceeing. So this is kind of a dry run for that, speaking into the nothing. I hope I'm doing well. All right. So tonight we'll have our introduction now. Marcus up first. He's from Contino. He will talk about the 3 musketeers: test, build, and deploy your apps from anywhere the same way. And then second, we have Kerim Satirli from HashiCorp talking about understanding the Docker provider for Terraform. After each talk, I'll pick a few questions from the respective Discord server, Discord channels. So we've got talk 1 and talk 2. The names are there as well. Everything else should be happening in the lounge. You can feel free to open a voice server. There's a voice channel where you can just watch this and talk to people if you want to. And then afterwards, we'll just convene over there and both speakers will go into their respective channels, so you can chat with them afterwards and just hang out in the lounge, just grab a drink, maybe order some pizza, just because I've not had pizza for months. Not like my circumference is any better for it, but I haven't had pizza in ages. Anyway, without further ado, I'm going to, I think this is my last slide. I'm going to stop my sharing. And yeah, I am going to ask Marcus to turn on his camera. Yes, there we go.
Cool.
Hello, how are you?
I'm good. How are you doing today?
Too bad, not too bad. If you got the container ship behind you as virtual background, I see. I think I made a point of it like a while ago to try to refrain from the container ships, but okay. I will hand it over to you. Good luck, and yeah, I'll catch you after your talk to do some Q&A.
Cool. So it's my first experience giving a talk online. It is quite interesting. I ran some training online before, but it is a very different thing not to see your audience and whatnot and kind of speak to a room. Kind of feels like every day on Zooms now. So cool. I'm going to present today on 3 musketeers. It is a pattern I've been using for quite a while. It's also a pattern we use a lot in Contino. And I will try to explain why we think it is like a great idea to use it. So to start off, Let me first start with who am I. So I'm Marcus Maxwell. I'm a principal consultant at Contino. I'm certified in a few things, and you can find me on Twitter. During my day-to-day, I pretty much work with like big enterprise organizations, which is kind of the bread and butter in Contino. And what we try to help with is like all the DevOps transformation stuff and a lot of pipelines, a lot of ways of working, and I'm currently actually leading a security team. So there's quite a lot of hats you can do in Contino. In that terms, Contino is quite a big organization. So if you're interested in joining, we're obviously hiring even in this climate. And let's kind of start off. So the agenda has 4 primary points. We have the problem, the solution. You probably know the solution by now. Some gotchas, and some other approaches you can use if you don't think like Three Musketeers is kind of up your alley. So let's first start with the problem. So before DevOps, it works in my machine. After DevOps, it works in my container, right? One of the most popular things that a lot of people try to solve, I think that like I started thinking about all this kind of automation back in like some Ruby days when some stuff like Bundler and Vagrant and everything else was getting kind of popular, was try to automate your developer machines and whatnot. Then you can use also those Vagrant machines somewhere else. Then Packer kind of came along and you could recreate all your stuff and kind of have that VM layer. And then containers came along, solved even more problems. But like the CI still was kind of different. And then Kubernetes came along. So the landscape of how you deploy and what you do and how you test locally and how you test on prod is quite different, right? And it creates quite a few interesting challenges. And in particular, I want to focus today on how it solves that experience on your CI/CD systems. So to start off, one of the main problems is that if you particularly work on like Jamstack or any newer things, you will probably see that everyone is kind of on different versions of tooling. Even if you're like on, for example, let's say Terraform, if you don't constantly upgrade your versions, you might have some team members on one version, some other members on the other. So for example, we like last year, we're upgrading from 0.11 to 0.12. And then you have these interesting solutions for how do you run multiple versions of Terraform, right? So there are some projects that offer that. We kind of opted up for Docker, and we just run it in Docker. But then how do you specify? How do you use tags? It kind of starts getting a little bit complicated. If you build any complex apps, you might see that, like, let's say you have a Hugo blog or you have something a more complex application, you might be passing a lot of parameters with how you want to build, like add minification, like all those parameters add up. You start doing aliases or you start doing bash scripts, and it gets quite lengthy, right? So you have to put that complexity somewhere, right? And constantly having aliases, it kind of works on your local machine, but gets kind of complicated when you want to go to prod. And it also works for you. It doesn't mean that it might work for everyone in your organization, right? The biggest problem I found was you can't replicate what gets run on the CI. And one of the reasons is like, let's say, I think 70% of organizations, like completely made up statistic, runs Jenkins, right? Almost everyone runs Jenkins, and everyone has like they really love writing a lot of Groovy to automate a lot of different components of it, right? So, but the second you start doing that, the second you start focusing on your CI instead of your developer experience, you might see that the way you run your CI and the build there is quite very different from how you run it locally, right? In some cases, you won't even be able to run locally what your CI is doing because you essentially will have to run a mini Jenkins on your own machine if you wanted to build it to the same standard, right? And that creates like a lot of pain points because if you try to debug it, the only way to debug your CI/CD pipeline becomes that you have to constantly do a git push and see what happens, right? And it gets quite painful. The other thing is that a lot of CI systems are still not Docker, so you might end up with a AMI that has your, let's say, Jenkins agent that you use for, and then you will have every single tool on Earth, right? If you didn't adopt Docker, you will have all the tools installed in your path, and then you have this massive AMI with everything that constantly runs on the platform. And building, if anyone like build like image bakeries, my bakeries, you will know that like it can be quite a lengthy process to actually go and rebuild one and add tools. And then how do you maintain multiple versions, right? And obviously, the biggest problem, also kind of similar to the Groovy problem, is that you start installing a lot of plugins on your CI system, right? You install a plugin to first to kind of do all your Git operations, then all the Slack notifications and everything else. Once you start doing a lot of that, you see that like your CI is more complex than your package JSON for your JavaScript app, right? So, and something that there are obviously good use cases. So for example, let's say you want to notify ServiceNow. That's probably not something you want to do from your local machine when you do these things. But when you do it on the CI, that's something you want, right? So there are some use cases that make sense. But for example, let's say you want to just push an image to a Docker registry. You really need a custom plugin that might not be really maintained anymore, right? So that's kind of the problem. And a big reveal, the solution is Three Musketeers. So Three Musketeers is essentially a pattern. It's not a particular tool. It's a collection of tools that you probably all know. So we have Docker, we have Docker Compose, and we have Make. So for some people, Make might be scary, but stay with me. Hopefully it kind of makes sense, right? So let's kind of go over the basics of how this all works, right? So on the left, we have your regular user. They can be running Linux, macOS, Windows, doesn't matter, or it can be your CI/CD system, right? And at the very start, what you will do is on your host machine, you will do run make. So your first command will be always executing make, and you can have a make test, a make build, or a make deploy. You can map it to what your tool does. So let's say you're running Terraform, you can call make plan. So it's just an equivalent of Terraform plan with some maybe additional flags. Or you can just say, well, I want to do, instead of Terraform FMT, I will just do Terraform test, make test, right? So to run some TF-lints and FMT. So that's one option. After that, your make will call essentially Docker or Docker Compose. You can pick if you want to have very small use cases. Maybe Compose is a little bit too much, but usually, like, it will simplify the various containers you run. And particularly if you have more complex applications that require a database or multiple containers to run, let's say a traditional LAMP stack or whatnot, you might want a database, for example, right? So with when you have Docker Compose, that allows you to test a larger size infrastructure. And then your task will be what you actually want to execute, right? So you will pass some command to the container, let's say Terraform apply, and that's what will run inside of that container. So all your if you're familiar with Kubernetes, you can say these are like jobs, or if you're just want to kind of understand what happens is, instead of running Terraform plan, what you do on your local machine, what you do is make plan that calls Docker, which calls Terraform container, and applies your plan by mounting your local directory, right? So it's a relatively, I think, simple context, but obviously I've been dealing with this for quite a while, and it's very powerful, right? So in Container, what we found was that we go on engagements with a lot of our clients. Some of them are on Jenkins, some of them are on different CI systems. We finally saw like quite a nice adoption of Docker, and everyone kind of works on MacBooks. You're not really locked down to horrible Citrix as much as we used to be. You're not as locked down to like a ThinkPad with Windows 7. So you finally start seeing a lot of more Docker adoption, which means we can start transforming our tooling where we don't need to jump into VMs. We can even work locally with Docker, right? And what we saw was that our pipelines, client to client and everything else, are quite similar. We always will have, let's say, if it's a traditional AWS engagement, it will mean we're building something like a AWS landing zone, and it means we will probably use Terraform, right, for it. And obviously, there's only so many best practices you can use. So at the end of the day, what you will be doing, you need a container with a version of Terraform. If you want to actually, by the way, Container has Docker host. We host all of our images on the Docker Hub registry. So if you want to use Three Musketeer compatible containers. You can check that out. And essentially what it allows us to do is to have a unified method for how we run Terraform and ensure all the testing and everything else is consistent the way we do from our local machines to the CI systems the clients have. And kind of make sure that anyone like from the clients team also have a unified way of to ensure that they can just check out the repository, run make, and they will have the same experience as anyone else, right? They don't have to do and follow like a Confluence page with 50 steps, how to set up your machine and whatnot. As long as you have make, Docker, and Docker Compose, you're pretty much ready to go, right? So this is essentially an example of from the official freemusketeers.io webpage. So the project has been running, I think, since 2016 or maybe even older. So it's been quite around for quite a while, this pattern. And this is the smallest version of what Free Musketeers pattern is, right? So at first you have a Docker Compose file. Hopefully you're on version 3, not 2 anymore. And you have services. And in this case, we have an Alpine service that uses the Alpine image, right? And that's all you need in your Docker Compose. Once you have that, you write a very simple make file, and you will have, in this case, echo, which will run a Docker Compose run, will remove the container, and then it will start the Alpine and send echo hello world to it, right? So if you do make echo, what you will end up is that it calls in makefile the echo command, runs the Docker Compose, and what you will get printed on your screen is hello world, right? So a very kind of simple pattern when you break it down to this kind of level, but it can get quite complex, and I'll show you now a little bit more of an advanced topic. Right, so apologies for I kind of wanted to visualize on a single page all the free code bases. So let's say a traditional engagement where you have some Terraform to write, right? So in this case, all we want to do is spin up EC2 instance and see if it works, right? So here we will have our Ubuntu 20.04, which was recently released. And this will just spin up one instance, right? So quite basic Terraform. And let's see how that works, right? So on the right, after that, in the middle here, we have our Docker Compose file. And you can see that I still was it was based on that example. So we have our Alpine image, we have an AWS image, and we have a Terraform image, right? So this uses one of our images. We have an env file that we pass. So all the AWS profile, AWS credentials that you will have, you can mount that into the container, so it gets injected as environment variables. And then we mount our credentials and we create a read-writable directory, right? So it mounts the current directory into opt app into that container as read-write as writable. Right, so basic Docker Compose stuff here. After that, we have a modern shell. So always kind of specify bin bash because by default it goes to BNSH. So you might see some idiosyncrasies. And after that, we have init, test, build init, deploy init, and clean Docker. So let's start with the first one, right? So if you are running on a new environment, what you might see that you don't usually push your .terraform directory, right? Which means every time you will run on a CI system, in theory, you should run Terraform init. And it's just kind of like best practice because maybe you added a new module, so a plan will not always go and work for you, right? So in this case, we have an init command, so it will go in init. After that, we have a basic test. So this is a Docker Compose run Terraform FMT. Add an additional flag called check, which will return if there are linting failures, essentially, and recursive to ensure that it goes into all the modules on all the subdirectories, right? This is particularly useful if in your CI system, right? You might want an additional command in your make called, let's say, make lint, which will run Terraform FMT without the check, and maybe we'll add something like Terraform lint, which is an open source project. So After that, we have build, which will essentially run init first. So this is just how the make syntax works. And after that, you will have docker compose run Terraform plan. So this will just run a plan for us. At deploy, we'll do the same with an apply. You might want to ignore also checking for any input to make sure this is more CI compatible, unless you want to enter yes in your CI, depending how it what support you have there. And clean Docker to just ensure like a classic make clean command, so it removes any stale containers. So this is a more advanced kind of scheme where you want to build more like that's tailored for Terraform. So after that, I kind of mentioned that the whole benefit of Three Musketeers is that it will run on your local machine and it will run on your CI system the same way, right? So here on the left, if you can guess, that is GitHub Actions. So on GitHub Actions, what we have is a little bit of fluff. So on pushes to master, we want to run a job on a Ubuntu latest image. We pass some secrets because otherwise of Terraform obviously will not work. And this is not running in AWS. There's a GitHub Actions hosted agent, so we need to pass keys to it. And then we have basic steps. So the first step that GitHub Actions will do for us is check out. Then we will run a make test, and then we will run a make build. So in this case, it will go check for any linting problems, and then it will do a plan for us and output that plan. On the right, again, steps, right? Even in Jenkins, I think it's now called steps. So pretty much every CI system on the earth, everything is YAML, right? Everything is YAML. Your CI system is YAML, your Docker Compose is YAML, Life is YAML. So on the right is a system that you might not be quite familiar with, but it's called BuildKite, which I highly recommend that you check out. It's quite a different way that you can do pipelines, and there's some fancy stuff you can do with it. And essentially, in this case, we just add some labels here, and we run the same commands. Which like it will automatically check out the directory, and here we will do a make test and then a make build. Right. So we have two different CI systems. And you can see that it's essentially the same commands that you will be running across both, right? So, and that's the nice thing, right? You run locally a make test, you run on a CI system a make build, and it all just works, right? So at least that's the promise. So just to kind of prove it to you, so in here I run a make build. You can see pretty much the same output. In this case, GitHub Actions in the middle, you can see I did another make build, and it first did an init, like here, and then it did the make plan. And then we can see BuildKite on the far right, that it again did a Terraform init, and then it did a Terraform plan for us, and it's all so it's all the same, right? The same outputs, the same inputs, so computer should produce the same thing, right? And that's kind of like the whole nice thing with Three Musketeers is that like if some, let's say the organization decides, oh, we don't like BuildKite anymore, we want to use Azure DevOps. Well, it will be much easier for you to move your pipelines and everything else if you are not super right? Because everyone kind of properly might remember, like everyone kind of used Travis, then we all moved to Circle CI. And like people just move around depending on like who offers a free plan, who kind of has better functionality. Now like GitHub Actions is getting very popular, right? So having that portability is quite nice, right? It also means like locally you're not beholden to your CI system, and you don't really need an advanced DevOps team just to like who will run your CI, right? CI should be quite like in my philosophy at least is like to keep it relatively simple, right? If your CI system is like quite crazy, maybe you're doing something wrong, right? Like maybe you're hiding a lot of complexity in your CI where it should live somewhere else. So obviously, if something goes wrong, I just wanted to add some memes. It works on my machine. Try not to be that. If you have the same thing, hopefully it won't happen to you. So That's kind of the basics of Three Musketeers, and now I will probably go into a few kind of asides that you should probably be aware of, right? So one of the main things are make files, right? Now, hate them or love them, because maybe you will just say, well, like I can just write a bash function, like that's easier. And make files make you use tabs, where everyone knows that spaces are better than tabs, right? So that being said, any modern editor like will convert your spaces to tabs and will make sure that your make files are compliant, right? So it's not that particularly just a pet peeve. And Makefile has been around for ages. It's a kind of proven technology, and it does simplify what like a lot of complexity that you will have to put into a bash script if you wanted to replicate what a Makefile can give you, right? So let's start off with kind of some basics, right? So first of all, use colon equals to ensure variables are set, because if you just say equals, it will lazy load them. So it will not evaluate them until they first get hit. So you will probably want to ensure that you always use that kind of syntax when you declare your variables, because we're not building here a super efficient application where we particularly need lazy loading. Then makefiles have something called phony, right? So you probably, for those who probably love building C applications and whatnot, you probably screened when you saw me in my makefile just say init and say test and build instead of actually specifying what phony. So by default, the way makefile works is that if you call make init, it kind of expects that you will be writing to a file called init, and it will check if that file kind of had to change based on your like init.c, right? So it's a very important thing to kind of understand that we're reusing make for some different purposes, right? So as long as you can ensure that you don't have directories or files called init, test, build, deploy, clean Docker, you can use the syntax without phony. But the second you might have, let's say, a folder called test, you will have to use the syntax called phony to ensure that it doesn't try to create a file, but instead runs just the command for you, right? So it's something to keep aware of, and phony is like not particularly the best naming conventions. It kind of takes a while to kind of get your head around. And then if you want to start off, like a good bash file will always have set AEX to ensure that it blows up and shows you some tracing and some best practices. In makefiles, you probably, like you saw before, you should want to specify your bin bash, so you use a more modern shell than just sh. You might not want makefiles outputting the command you're going to be running. So you just want the output of the command instead, particularly like in CI systems. So you can just set verbose to silent. And it's usually best that when you write your make files that you have by default, if you just run make without any parameters, it will default to help, right? So you show like you have a basic kind of CLI utility there, right? So with that will show you like which commands are available and what you should run, right? It's a functionality you can build in. So after that, there's a few things to look out for. So first of all, obviously, the beautiful goal of idempotency and ensuring that everything works, you need to follow some Docker best practices. So if you use latest, then your images won't be idempotent. So unless you work in a team where you want to constantly grab latest images, you might want to see that that's actually not the best for you, and you want to lock versions, at least in Docker Compose. So always kind of specify versions, and kind of there's a great blog post on like Microsoft's site regarding immutable images, right? So like if you don't use latest, don't even use Samver, you probably want a Samver plus a build ID to ensure that uniqueness, right? So that's one way to approach it. the other problem is try to use the same secret management solution, right? So one of the biggest problem with the Three Musketeers approach and just testing locally and on your CI system is that your environment variables might be different, and the way you have permissions will be quite different, right? So for example, if I run locally on my machine, I will probably have a AWS credentials file, or I will go STS and grab some credentials via like Azure AD and whatnot, and that's how I get my AWS keys, right? If I run on a CI system and let's say my build agent is on AWS, it might have an instance profile, and by default, Terraform will know to just call out to AWS APIs to grab a token, right? So, and if I run on like GitHub Actions, then I need to use a secret management solution where it will go and grab a secret and retrieve that, right? So it can get quite complex where all your dependencies are. So if you use something like Azure Key Vault or Secrets Manager or Vault, preference obviously always is HashiCorp Vault, that you go and build that in, that even locally you try to go to HashiCorp Vault, for example, so you grab all your secrets, right? If you constantly have secrets in different locations, at least agree the way you import them. Like agree either that you inject everything as a file and then you read those secrets on the start of the container, or you insert them as environment variables, right? Environment variables are more kind of pervasive, I think, but they're not the best solution from security perspective, obviously, because if you get into that container, you export the variables in the environment and you can see everything, right? If you read from file into memory, it's much more difficult because you will have to inspect memory, just as an aside. The other thing is that even though we only have make as a dependency, Docker and Docker Compose, you will probably find make on most Linux machines, but Docker and Docker Compose versions are quite different, right? If you're running Red Hat 8, it's actually renaming and using Podman underneath, and you don't want Podman because you want to use Docker Compose, right? So you have a problem there, right? So you need to ensure you download the proper version of Docker. After that, your version of Docker might be different between the hosts. And for example, I was doing some of the examples for this talk. I was trying out Ubuntu 20.04 as my build agent. I installed apt install Docker Compose. It installs version 1.25.0. That actually blows up. It cannot load an N file. I had to download the official, like a newer version of Docker Compose with 1.2.5, right? So there is obviously an approach with which you can fix and lock it down to only Docker itself, which is you can use Docker in Docker, right? If you use Docker in Docker, which has its own gotchas, obviously you can have a container that will have both make and Docker Compose at the versions that you want. So your only dependency on the host will be that you need Docker, and that's pretty much it, right? So it's an interesting pattern, particularly if like you build containers. It's something you can explore. So we will see. The other thing is that very often you will want to publish something when you run in your Docker container. So maybe you will have like a log that you want to store on your build agent, or you're mounting some secrets or mounting your SSH keys. You will probably very quickly start exploring the beautiful world of permission problems when you're running Docker. Now, if you're really security conscious, what you will want is to ensure that you run Docker containers not as root, but with some random user, right? So always, like, the best practice in Docker is that you always have the user flag, so it always runs as a regular user. There's two approaches. You can have rootless containers with kind of like PassWD, or you can use also Gosu, right? So there's quite a few interesting gotchas if you use rootless containers, if you use Gosu for your sudo equivalent. So you need to be aware of those kind of things. And because it was a lesson hard learned, and obviously thanks to all the continues that I work for, because I wouldn't we wouldn't solve all these problems without them. let's say you don't want to run your containers as root, right? So like I said, we have an org, which is Docker user, and here we run our container as Docker user, not as root, right? If you have a Docker file like this, you might find that if you try to mount your SSH key, is that your local MAC will be, let's say, user 900 or something ridiculous, but the user in the container is user ID 1000, because that's usually by default what it gets created at, right? If you try to run your SSH key from that container, you will see that it will properly bump out. And the reason it will do that is that your SSH key hopefully was chmodded to something like 400, so you won't be able to execute it, right? Now you can't do on your container, and you don't have root anymore, so you can't just go and chown it, right, when you mount it. So you kind of start hitting some interesting permissions problem, right? So there is a kind of a little bit of a hacky way, but it ensures kind of unity across all your machines, is that you can't really guarantee the user of everyone on your team, right? Like my user might be called something else, but the UID for like me can be 501, for someone else it can be 502. It's a little bit hard to control which UID like ID you get. Like on someone on Linux might have a different one. So it's quite important that, and this obviously kind of breaks Windows compatibility a little bit. So in this case, what we do is in the make file, we specify the ID that I have, and then we will run our container as that UID. We then will mount also by default a passwd file into that container where we will specify the ID of that user to ensure that we essentially our local user and the user in the container are the same. So we kind of run a fake passwd file, and then we copy the passwd file there, right? So what this will ensure is that your permissions in the container are the same permissions that you have on your local machine or on your CI system, right? So obviously to achieve that, you have to fake a little bit with passwd, because if the IDs are not there, the Linux subsystem just doesn't know how to implement this, right? So this is one way you can solve your permission problem. And so it's something to kind of be aware of. Now, Three Musketeers is obviously not an end to all. You can achieve this in different ways, and particularly like if you are on Kubernetes, like it might not really work, because like Docker Compose only will work in a Docker and Docker approach if your build agents are all Kubernetes agents, right? So there's quite a few ways people try to solve this, and I will probably kind of go over a little bit of a history, because it's kind of an interesting aside to see how this Three Musketeers approach compares to everything else you could be doing, right? So one approach is Two Musketeers. So if you get into the Three Musketeers kind of sub-community online, you will probably find some blog posts saying, well, I don't like make, I don't like this, and then like, this is too complex. Why do we need Three Musketeers? We can just use Two Musketeers. So Two Musketeers is an actual website, and what it is just Docker and Bash. Right, so you have only Two Musketeers. So it is a bit a kind of funny project, but it actually seems to be quite serious. So essentially, it's 100 lines of Bash that tries to emulate what you will achieve with Docker Compose and Make. So if that's kind of more up your boat, sure. I find that the complexity of running some Bash that's quite hard to read probably doesn't qualify it, right? But again, it is an approach. Another thing that a lot of people try to solve is just to have some kind of script, and this mostly just solves your local development environment. It doesn't particularly solve your CI system, right? So Thoughtbot, which were very popular back in the Ruby days, and they're still going strong. This is like something I used ages ago. Is that they will like have a script that will go and bootstrap your machine, right? It's something that you want to have across all your developers in an organization. You want that kind of parity of environments to ensure that there are no gotchas, right? So this is one way to achieve it. You then had the world of Ansible and Vagrant, right? So particularly in like PHP community, for some reason, I find there's been a lot of boxes created with like Fanciful was one of the more popular projects. It's still going, where you will have essentially generate a Vagrant machine that has everything to run a traditional like PHP stack, so like Nginx, MySQL, and PHP. The other thing is a Devilbox. So this is a more, let's say, cloud native approach nowadays. So it's a Dockerized PHP stack, right? So you have LAMP and mean if you want to run it, and you get a lot, right? So it provides you a reproducible development environment for pretty much everyone, right? But you can kind of properly then just take that and run those containers in prod. That being said, we probably all learned the lesson that running just compose on prod probably not the best idea, right? That being said, very cool approach. If you don't care again about your CI as much, something you can kind of take steer for, right? And then we have the most cloud native option. And this is something that I found similarity between the way the serverless world tried to approach developing on local machines, right? So anyone who did any Lambda in their time probably will know that all the mock services and whatever else are not really there, right? You like can't really run a local Lambda AWS stack with all the services as much as there are like mock services out there. It's still better to test against a live environment, right? Now with Kubernetes, it's a little bit different because you can run kind and you can have a Kubernetes stack on your local machine. But then your local Kubernetes stack will probably be quite different from the OpenShift or Kubernetes cluster that you are running in production, right? So there's quite a few projects. I think there's one called Tilt and another one is Garden, where they allow you to develop against a production cluster or against your local cluster in pretty much the same way that you will be doing, right? So if you want to do your tests and deployments, you can probably use Garden and it will achieve the same thing. So for those, particularly in Kubernetes world, that's kind of like a very interesting pattern that like I'm kind of trying to observe. But obviously, if you're just running some Terraform, there's way too much, right? This is particularly for building applications on a system, right? So those are kind of the primary approaches. And obviously, another meme, it works on my machine, then we'll ship your machine. And that's how Docker was born, right? That's pretty much all of our life now. All we're doing is building containers and hope that they will run on our orchestrator of choice, which is Q, right? So for those who are interested in a lot more, because I kind of hopefully run quite fast through the whole talk, there is quite a lot more on the Three Musketeers website. There's a lot of water patterns of how you can approach Three Musketeers, how you can just run it with Make and Docker, how you can run Docker in Docker. You can read the whole story on the amazing blog, so do check that out. You can check out the way we do our containers. So we build our containers with the Three Musketeers pattern that we use for Three Musketeers. So if you want to see how we implement that, you can check that on GitHub. And one of my colleagues in Catino manages a serverless Golang container. So if you want to go and check that out too, it has a Three Musketeers pattern in it. So if you search for GitHub also for Three Musketeers, you can see how kind of prevalent the pattern is and kind of see like the benefits, right? So try it out, see if you like it, and that's it for me then.
All right. Thank you very much. Yeah, let's go head over to one of the questions that I found somewhere in the channel. Just for people who are not on the Discord server, you can win a JetBrains 1-year free license if you ask a question, and Marcus will pick the best one. So if you want to win, get asking. Where one question from Mr. Hardy. He's been reading a bit about Capitan. Doesn't that do the same or similar thing?
You could. I'm not. I remember using Capitan, but Yeah, maybe. I'm not as familiar with the solution though.
Excellent. Let me see if there's anything else. But another question from Mr. Hardy. Between Devilbox and Garden, you mentioned another tool. What was it?
The other one was Tilt. So Garden and Tilt are quite similar. So there's quite a big ecosystem of tools regarding developing for Cube. So if you want to check that out, I think it's just called Tilt.io, something like that. It's on GitHub.
Cool. Another question from Rashmi. What are the disadvantages of the Three Musketeers pattern?
I think the biggest disadvantage for Three Musketeers is it depends on what you're trying to do, right? The biggest problem I found is a lot of people are moving their CI systems into Cube, and I'm still trying to figure out a good use case for Kubernetes to replace Docker Compose. So I have Kind on my local machine. That's how I run how I run Kubernetes. But let's say I wanted to use jobs in Kubernetes, which is a concept, to execute all my things, right? Now, it is really hard because it just runs against the cluster, but it's a non-interactive, which is bad or good. But the other thing is that the only way to see an output of a job in Cube when you launch it is to ensure that you do kubectl logs, right? Which is not ideal. So I think that's like the biggest problem is that if you are full on Kubernetes and all your build agents are Kubernetes, the only way to use the Three Musketeers pattern effectively is to use Docker in Docker. Now, that's a totally valid point, but obviously it creates its own kind of either security problems or it might not be available if your CI agents don't allow you Docker in Docker. So it's something to remember.
Thank you. And then final question from Dipito. If you're looking to use Three Musketeers for infrastructure development, how do you test that without having access to the full cloud environment, i.e. a Terraform plan?
How would you test your whole environment if you didn't have access to your AWS? Well, you will pretty much be in the mocking space again, right? I would say that if you want to test your Terraform without it, you will probably not be able to do any plans or deploys, but what you can do is static testing, right? So you can use Sentinel, you can use Terraform compliance, you can use various like local testing stacks for Terraform. But there's quite a few of them nowadays, right? But you obviously will probably not be able to do an apply if you don't have the Amazon APIs.
Cool. Well, I've got one more question if you are up for one more. Otherwise, we can also like direct it to the Talk One channel on the Discord server. Should I do one more?
Yeah, sure.
Here's a question from Harris. The question is, what tools or other ways do you recommend for debugging issues?
So if you want to be debugging issues, I will probably first start exploring the beautiful world of sysdig. If you have any problems with like any of your stack, I found that like being able to run sysdig on your local machine like will give you a lot of nice view. After that, the BPF tooling set is getting quite advanced and quite nice. So particularly like you can have dtrace now on Linux machines and whatnot. So that's another avenue. The other way, if you want to really debug things, try to just understand how verbose mode work and kind of how to just do basic strace, right? Those tools will always kind of help you out in many spaces.
Cool. Well, there are a bunch of other questions on the channel, but I think it's time for Kerim to take take. Thank you very much for your time tonight, and I will see you on the server.
Yep. See you there. Bye.
You're here. How are you?
I am doing great today. It's a beautiful day. Sunny.
You're coming at us from a different country right? You're coming from my home country, you're right now.
I am. I'm all the way over from Amsterdam. So I'm hoping the latency is not too bad.
Come on, make sure the cables are doing as well. No, it's probably going to be fine. Thank you so much for joining us tonight as well. And yeah, so without further ado, I think you can pop on your slides.
Let's do that.
Right, good luck.
So give me a sec while I get the Zoom set up. Then let's kick this off. So good evening, everyone, again, and thank you for joining us today. I had the pleasure of being in the waiting stream, and that was some of the best holding music I've ever heard on a live stream. And I watched a lot of them. So my name is Kerim Satirli. I've been working on IT operations and automation for the past decade. Huge fan of complex systems that work well and, most importantly, work predictably. I'm also the British spelling. I'm also the organizer of the Amsterdam HashiCorp user group, which incidentally is not run by Dom. Not yet, anyway. But congratulations on the new job. It's pretty good to have you here.
Thanks.
Also pretty good to be here. So if you have any questions after the presentation that you don't want to ask in Discord, or just want to talk about Asian whiskey or baking cakes, you can find me as K Satirli on Twitter, GitHub, Keybase, and many other networks. But if you send me DMs on Instagram, that's going to be creepy, so let's not do that. So I think that Marcus showed us an interesting pattern. I, for one, love makefiles and bash. To me, it's one of those art forms that people stopped using for whatever reason, I guess because JavaScript came around and you can do everything in JavaScript. And we're not better off for that, but that's a different topic. So let's talk about infrastructure as code. For tonight, I'd like to take you on a 25-minute journey on how you can use Terraform to make your IAC, so infrastructure as code experience, a little bit better. We'll start by looking at some of the basics of Terraform, and then we'll jump right into managing Docker with Terraform. And I'm going to say the word Terraform a lot because obviously that's what I talk about. And for the last few minutes, I want to share a few thoughts with you on where I think your journey could take you next and how you can expand your skill set. So I've structured today's session in a way that we'll be looking at code. I'll be explaining it, but you don't actually need to code anything yourself. I'll be sharing a repository afterwards with you, so you can just git clone and go wild, or not, totally up to you. So Terraform is an infrastructure as code application that enables operators, so folks like you and me, to create and maintain infrastructure components predictably. And as an operator, if you've ever done on-call duty, things that work predictably are the best kind of things. You don't want to be scratching your head. So, for me, Terraform works. And the way Terraform does that is it uses a system called providers. These support a super expansive range of external services. Each provider on its own is responsible for understanding API interactions of an upstream service, and it then exposes these interactions as resources and data sources that you can use through Terraform. So quick stats, HashiCorp maintains roughly 125 official providers. So we have Azure, GCP, AWS, Datadog, Docker, of course, and many more. And then there are roughly 175 currently listed community maintained providers for services such as Auth0, the Sentry CI service, even the unified networking hardware. So if you want to use Terraform to set up your home network in a proper way, and given that you're spending all your time at home, Terraform can help you with that. So in today's session, I'd like to show you how to use the Docker provider for Terraform. To manage your Docker host, or hosts if you're that kind of person, in a more structured way. So let's get to know Terraform a little. Terraform itself is written in Go. But when you write code for Terraform as an operator or developer, we're not exclusionary here, you would do that in a language called HCL. That's the HashiCorp configuration language, or as Mr. Hardy called it on Discord, I think HashiCorp's weird version of YAML. So HCL is a common language supported by all of our tools. Learning HCL is honestly a really huge investment in an ecosystem that can take you from a single machine, a single bucket, to a full microservice architecture, spanning several different cloud providers, continents, anything you want, really. So HCL supports all the things you would expect a configuration language to have. This includes variables, interpolations, and many more things we'll be looking at in a few minutes. All right, so with this bit of theory out of the way, which I promise you was important, let's look at a more applicable part. So let's start with the code editor and actually get some of the things we just talked about into Terraform. So in Terraform, you define providers with the named block that identifies the provider. And in our case, this is Docker. But if you're using AWS, this could be AWS or anything else. Whenever you set up a provider, you want to set a version string to pin your resources to that specific provider version. Think of this as using an image tagged latest versus an image tagged with a version string. Or even better, a SHA-256 checksum. So to echo what Marcus said, you'd always want the most idempotent option, not the most fragile one. Saving 5 letters of typing or 20 characters, whatever it is, during development is not going to make anyone happy when you're running this in production and scratching your head. It also makes it easier for future maintainers of your code base to understand which version of the provider documentation is applicable, as we add features pretty much all the time. So back to the Docker provider. Next, we set up the host. And in this case, I'm using TCP, and my local host. But I could also just be using a different approach through Unix sockets or even a remote host. The Terraform Docker provider will connect to any Docker host it has access to as long as you specify it. And finally, I'll add a block for registry authorization so I can download private images from our Docker Hub organization. And in this case, I'm reusing my system's Docker file. Obviously, if you use these code examples, make sure they have your data in there, make sure they have the correct registry in there, and go with that. So our provider is configured, and we're done for code editing right now. So let's switch to a terminal. And the beauty is I use macOS built-in terminal, but you can use iTerm or even ISSH if you want to run this from your iPhone. So to set up your provider, you'll use the init command. And you can think of this as the git init of Terraform. I think that's a pretty good way of understanding this concept. So it's a helper command that sets up your local directory with the right files for all the providers that you configure. And in our case, that's the Docker provider. And you end up with a new directory called .terraform. Hidden, don't commit this to your code base because this is only relevant to you. And if we dig a little deeper, we can see that Terraform downloaded, in my case, an OS-specific and macOS-specific version of the 2.7 provider. Now, back to our editor, because now that we've initialized our provider, we actually get to play with it. So We'll create a new resource, which we're naming Minecraft, because realistically, that's the best use for Docker, especially when you're working from home. And we'll pull the 1.12.2 version of the image. Now, before we continue, note the version string. Generally speaking, we don't want values that change often to be hard-coded. So let's go ahead and turn it into a variable. For simplicity, I'll name the variable image tag, but you should always, no matter the language, have variables with names that are as descriptive as possible. Terraform helps you out with this by preventing the use of words such as version as a variable name, because realistically, those generally do more harm than good. Next, we'll add a type to define what kind of data a variable should expect. And down the road with 0.13, Terraform 0.13, and later versions, you'll actually have a lot more control in terms of defining what type of content a variable is allowed to have. So here we're setting it to string, but it could be a number, it could be a Boolean, could be something complex, such as a list, a set, or a map. And finally, we're adding a description and a default value, again, for 1.12.2. So now if we update the Docker image resource with the correct variable reference, Terraform will resolve the content of that variable and will pull the correct version of the Minecraft image. So at this point, I know we're going super fast because everyone wants to play Minecraft, but we also have enough code to test things out. So let's go back to terminal and try out a plan command. And so what this does is it generates an execution plan and it shows what Terraform is planning to do. And this is a very useful command because it takes the guesswork out of your work. So here I'm saving the plan using the out argument. And this way, even if something changes in the backend, Terraform will execute the plan exactly the way I showed it, or the way it showed it to me, and the way I approved it. Now, of course, if you're using the Docker provider locally, hopefully nobody else is messing around with your Docker host. But eventually, you might end up configuring remote resources with multiple engineers that work on the same project. And this feature becomes a lot more important. So Terraform processed our files and it is now telling us what it will do. And we can see that 3 arguments are highlighted. So for some of those values, Terraform already knows what the resulting value will be. We specified the name, but for others, such as the ID value, Terraform informs us that those values will only be known after Terraform apply. And this has to do with the way some of these values are generated. In the case of an ID, this is provided by the Docker engine. So Terraform can know it before you've actually provisioned the resource. So pretty good. So our plan looks good. And it's time to actually provision our resources. And this is done using the apply command. And if you remember from the previous step, when we use Terraform plan, we specified an out argument to generate a plan file. And that file, the output from the plan step, now becomes the input for the apply step. And I should point out that in general, TF plan files are for execution runs only. So you would, generally speaking, want to avoid committing them to your version control system. So here, I'm running Terraform apply, and you can see that our plan is executed in seconds, and we're good. Obviously, the timing really depends on what your infrastructure looks like. with a single container or even a handful of local containers that you already pulled, everything is going to be blazing fast. Let's say you're working with a cloud provider. Earlier today, we mucked around with some RDS database instances on AWS. Each one of those takes about 18 minutes to complete its run. Because in the backend, AWS is actually provisioning the resources that Terraform instructed to and creates backups, and all of that takes a little bit of time. It's one of the reasons why I like using the Docker provider. Locally, everything is always nice and fast. And so if you have a look at the bottom of the output, you see that Terraform has actually saved the state of our infrastructure into a file. And so this file, the terraform.tf state, is a mapping of real-world resources in your configuration. And, having been stuck at home for 2-3 months now, I don't even know what real-world resources means anymore. But I am told that we're talking about Docker images and Docker containers that run somewhere. And right now, that's like me, it runs at my home. So next to that state file, keeping track of real-world resources, it also keeps track of resource metadata. So in our case, that's provider identifiers, image tags, what have you, volumes, volume mounts, of course, networks, pretty much anything related to the resource you're provisioning. So even though you might have maybe 3 to 5 lines of Terraform code to define a Docker image, Terraform itself might know 100 lines of data from that same resulting image. And so, more important for later, the state file also helps keep Terraform performant. So when you have large-scale infrastructures, you don't have to worry about waiting for everything all the time, unless you use stuff that actually takes a long time. So by default, your state is stored locally in a file called terraform.tf state, which is great and totally fine if you're the only engineer working on a project. But I really recommend storing it remotely, even if you're the only engineer, because if your machine dies and you lose the state, things get a little bit messy. So in the code samples I will share with you later, I've actually included some reading material on how to store state remotely. So let's go back to our code. And let's say we don't want to hard-code our variables in our .tf files, right? Because we don't want to version them, we want to build modules. There's a handful of reasons of why you would want to avoid hard-coding data. Secrets, always a good thing to keep out of your versioned code. So to keep our Terraform files clean, we can use variable definition files that end in .tf vars. And these files are key value based and allow for specifying default values that Terraform will pick up. So if you remember from before, we defined a variable. Even if a variable has a default value, but you specify that variable's value in a terraform.tf vars, that overrides the default value, which is exactly how you think a language should work. So generally, the convention is to have the file name in .tf vars. And if you name them terraform.tf vars, Terraform will pick up the file automatically. And for larger projects, you may end up having multiples of these files. So as long as you name them anything that ends in .auto.tf vars, Terraform will still pick them up automatically. And given that Terraform is written in HCL, which is not only machine readable, it's also human readable and JSON compatible, you could also supply your your variable files as JSON, which means if everything you have right now is YAML, all you need to do is convert that to JSON and you're good to go. So let's jump back to our code editor. While I was talking, I did some sleight of hand and I moved the variables for the image tag to a file called variables.tf. And completely forgot to update my slide because obviously this should not be saying var.version, it should be saying var.image tag. And I'll make sure that is reflected. So let's add a new resource for a Docker container. We keep the same name here because that makes sense to me, because it removes confusion. And let's specify both a name and a dynamic reference to the Docker image we selected earlier. And so what you see here is one of the best features of Terraform. Dynamic references to other resources. And these references follow a super simple structure. You start with a resource type, so Docker image in our case, followed by the name, which is Minecraft. And finally, you specify the attribute you want to look up. And in this case, we want the name. Behind the scenes, Terraform resolves this value and fills it in for us. So down the road, if the Docker image resource that we have defined in line 1, 2, and 3 changes, the Docker container resource will be updated without us having to change code there. It's pretty nifty. And also removes the need to redefine the same variable over and over again. So let's test this out. We've already executed Terraform plan command to save some time, so we can jump directly into the apply command. And after a few seconds, again, running this locally, we can see that everything worked out as planned. And if we scroll down a little bit, there we go, another successful run. And take a deep breath, give yourself a hand of applause because you just learned the basics of Terraform. And you too can be a cloud engineer now. So for the last part, let's have a look at how we can make our code a little bit better. So we just wrote a ton of Terraform code. And Mark has also touched upon this, but this is one of the topics that set apart a good engineer from a great engineer. And with all the resources we just wrote, I've been writing Terraform for many years. I trust that my code is good. But I think it is always worth pointing out that Terraform comes with its own format tool. It's free. It's included. So there's really no reason to not lint your code. Run Terraform FMT. And just as Mark has suggested, use the options to lint files recursively, check variables. I like to print out a diff and clean up your code and format it according to our internal rules. And if you write Go code, you can think of this as Go FMT or Go format. Next, we'll use Terraform validate to validate the code we just wrote, and essentially just a sanity check that verifies if our configuration files are good, but we're not actually calling any remote services. And I should mention, remote in this case also applies to the Docker host we're running this on. So my recommendation for both of these things, use them often, find a plugin that works with your editor. There's really no reason to have shoddy Terraform code around. So, well, here we are. We've got a couple of resources. We've got an image, we've got a network. So let's see how our image, our container looks like. And this is going to be fun because if you remember the image we started up, we're essentially putting Java into Docker. And Java in Docker is exactly why Docker was created, according to the Oracle salesperson I spoke to earlier this week. Not sure how true that is, but they were really insistent that that was the reason. And they had a great solution to sell us. So let me start up Minecraft, and this might take a few seconds because we've got a pretty heavily modded Minecraft edition here. And fun fact, when you look at the repository later, you'll find that this is the same Minecraft image we use for our HashiCraft YouTube series. It's essentially two geeks playing Minecraft, provisioning resources, or attempting to provision resources while playing Minecraft. So everything is loaded, I think. So let's do this. And so I've got my server logging in. This works out pretty well. Let me see. Not sure you can hear my sound, but luckily there's included. Oh, crap. Slightly the wrong command. Okay, well, let's go to the next one. Turns out double tapping space ends your flying, which is not what I expected here. As you can tell, I'm not a pro Minecrafter, but I can definitely tell you a lot about Terraform. And I think we just did that, which is beautiful. So looking at my slides, that's pretty much all I have for today, but I'd like to briefly review. So we talked about the providers and the ecosystem. We looked at the Terraform lifecycle from initial setup to code validation, plan execution. We didn't talk about destroy because it's your local machine and the destroy command may not always be needed, but it's a good one to know. So I'll include a link for that in the code I'm sharing. And then we saw how great I am at playing Minecraft, which given that crash isn't all that great. So if you want to try the things I showed you today on your own machine, on your colleague's machine, take a note of the link that's shown. There, you'll find code samples and further reading material that I think is helpful to review. You could go to learn.hashicorp.com if you like Terraform and want to learn more about it. We'll have guides there for obviously Terraform, but also our other tools. And then for a more interactive experience, head on over to our Discuss forums. It's a community forum where you can talk to fellow practitioners, HashiCorp employees, and finally, there's something I'm super excited about, and I know Dominique is too. From June 22nd to the 24th, we're hosting our first digital event. Well, first large-scale digital event, which is called HashiConf. So registration is free. We have a couple of thousand people already signed up, so I highly recommend signing up as well. Follow along with our keynotes, product announcements. If you can make it, definitely attend a workshop. There's some really good stuff coming up. And all in all, just have a great experience. So my name is Kerim Satirli. It has been an absolute pleasure failing for you at Minecraft and to talk to you. Now, what questions can I answer for you?
Thank you, my friend. Cool. So
There we go.
so yeah, I just unshared your slides for you. So you know, that's the power of
Very good.
being a host. So the HashiCraft, I want in, man. Like Rob has been showing me lots of like Minecraft videos, and now I'm like, maybe I should start playing it. And now you're all like, HashiCraft is okay. So we'll talk about this later. So
HashiCraft is definitely worth checking out. It is literally what it sounds like. We built our own studio in there, including a green screen, which if you ever played Minecraft, really is just green blocks, but don't tell anyone because it looks super official. And we're mostly playing with Azure resources. We're bringing in some Nomad, and we're showing how you can provision infrastructure.
Cool. Yeah, so for whoever's still watching the stream, please, if you go to the Discord channel, don't forget to hit the thumbs up in the welcome channel so you can see the other channels. And don't forget to tweet and ask your questions to win the JetBrains license. So I will be having some questions for you now. At least there's a few. From Fernando, isn't the GCP provider fully generated from the Google API unlike the AWS one?
That's a really great question. So is the GCP provider fully generated? I would say it's generated for about 98%. They use a technology called Magic Modules, which ends up being used for their Python stuff, which I think is a G-Cloud CLI. But also for our provider, it's super nice because it means that a lot of the resources in Terraform are available immediately. AWS, on the other side, is artisanal. People hand code that, and the team that's working on that is doing a phenomenal job supporting new features, like new regions pretty much a week after they come out. They do weekly releases, and there's some pretty good stuff coming up for that.
Cool. Let me just scroll ahead. Thank you for answering that. Where did everything go?
So I think what Aaron points out there is indeed the case that we struggle with. If you don't have a consistent API, it's really hard to build resources for that, which is one of the reasons we're working and partnering with AWS to make this a lot better.
Yeah. And then a question from Rashmi. How do you ensure that Terraform is secure, like images used, etc.?
So let me see if I can find that question because I would like a little bit more context.
That's literally the sentence. It's the last one.
Ah, cool. Nice. See, even Trump is applauding me, so I know I've done something good. I think the images you're using, defining if they are secure or not, obviously that's an organizational thing. Terraform will run any image, no matter if you use root, no matter if you install a lot of dependencies. So we really don't bother us with that. That being said, it's definitely worth looking into your build pipeline and making sure you can sign it there. CoreOS has a couple of good tools for that. I think Claire, if I remember correctly, was pretty good. If you have a couple, well, tens of thousands of dollars to throw away, there's also commercial tools available. Yeah.
Dollars. Yeah, all right, cool. Thanks. Just scrolling some more. Anyone else have a question? Speak now or forever not be on the stream.
Well, while you dig up a question, let me follow up on what Rashmi said, because I feel that there's a secondary question beneath that, which is how do I ensure that Terraform is secure? So how do you make sure the credentials you use, especially if you use something like AWS, are not leaking? And for those, you could use Terraform TF vars, which is great. And as long as they're in your git ignore, then there's really not a problem. But yeah, obviously we have a product for this, Vault, which will generate credentials for you that auto expire. And I think that's what it comes down to. You want to have credentials that if they get leaked because you accidentally commit them, you end up with credentials that are essentially worth nothing.
Yeah. Well, I've been learning a lot about all of the HashiCorp stuff recently, so still in week 3, so yeah, it sounds like the right thing to do. Cool. Is there anything? Oh, there's like an Animal Crossing. All right. So with that, I'm gonna say thank you very much. And if you
My
can
pleasure.
hop onto the Discord server, that would be great. Marcus will be there in his channel. There's lots of other stuff. I'm gonna grab my drink because I think it's not it's. I'm trying to keep some sort of semblance of how the meetups generally go. So I'm just gonna grab a drink, order some pizza, and then slide into the server.
Nice.
Yeah. For everybody else still watching, thank you very much. Um, and I will see you later. Please, if you want to give me some feedback, that would be great. You can reach me on devopsdom@docker.london or DM me on Twitter or on the Discord server or wherever. just get in touch with me. I would love to make this a better experience for everybody, and this is our community, so the better we can do this together, the more fun everybody will have. So with that, I wish you a wonderful Wednesday, and I'll see you next time.
Thank you for hosting us.